Hello everyone. Today I will start with interfacing program where we will understand the interfacing of 4 cross 4 key matrix with LPC 1768. So here as you can see 16 switches are there arranged in 4 cross 4 matrix, 4 rows and 4 columns. Row 1, 2, 3, 4, column 1, 2, 3, 4. So in my previous lecture, already I have discussed the theoretical aspect of interfacing. Here, I will focus mainly on embedded C program, which we will use to interface this key matrix with our LPC 1768. And here is our program. In this program, the idea is to first interface key matrix with core, and then whatever has an input we will give that input, we will display over the output LCD display unit. So here in general, we are interfacing one input peripheral which will act as an input to core and one output peripheral that is LCD display unit. So to understand this program, we will not go in detail about the LCD display that we will discuss in some other lecture, but we will use some of its function. So that's why we have included the file itself. So some of its functions directly we will use. But to understand the key matrix program, nothing we have to worry about this display file. It is just whatever we will give as an input, then we will output it over LCD display unit. So as the theoretical aspect of interfacing, you must be aware about that four of its either the row or the column should be connected with four input pins, and rest of either the column or row should be connected to the output interface, output ports or pin. Input port and the input port pins will be used for monitoring purpose. So initially the value over those pins will be 0 because those pins are directly connected to the ground value, that is 0 value. Here in our case, all column 1, column 2, column 3 and column 4, those are all grounded and connected to the port number 1, pin number 23rd, 24, 25 and 26. It is wrongly written here 24 two times, but it is 23, 24, 25 and 26. So column 1 is connected to this, column 2 is connected to this, column 3 and likewise column 4. So initially the value over these pins is 0, and if the value over these pins is 0, that means nothing being pressed. So these input pins are for monitoring purpose. So how to monitor it? So for that purpose, we will regulate our outputs. We will regulate our output. So suppose if corresponding to row 1, if any one of the column being pressed, corresponding to its column pin, the value will be 1 only if the corresponding R1 should be connected to the output pin and its value should be 1 at that time. If the value of that pin is 1, then its corresponding column can get the value 1, and then we can understand that something over that row being pressed. So here for an example, if I want to press switch corresponding to the key value 4. So this is the switch which we want to press. This switch is corresponding to row R2 and column number 1. Initially the value is 0 till the time we not been pressed the switch 4. Till that time, the value over the column 1 was 0. The moment you will press it, and at that time, the value over the pin number 2.12 is 1. So this 1 will come from here, and this one. So it is P2.11. At that time, P2.11 should be 1. Instead of P2.12, P2.11 should be 1. So if this value is 1, this value 1 will come over here, and from, because now we have pressed the switch number 4, and this will go there, and the 1 will come here. So P1.23. The moment this 23rd pin of the port number 1 become 1, that confirm that corresponding to column 1 and row 2 key switch corresponding to 4 value being pressed. Then the moment your core will get the value 4, it will provide this value 4 to output over the LCD display. So that is something which we will see through the program. And to understand the program, once again I will come back to this scan code. Before that, we will start with our program. So here in our program, so initially this is scan code. The scan code is something which we will generate, which we will come up in our program that confirm, because 16 keys are there, 16 switches are there corresponding to that, and for 16 switches, so these are arranged in 4 rows, 4 columns, 4 rows. So corresponding to 4 columns, those are attached to 4 pins. Likewise, 4 rows are attached to 4 pins. So these 8 pin value we will arrange in some way, and then because it's specific to every key being pressed, to either either it has a specific column or a specific row value. So the combinations are 16 in number. That 16 number we will generate through our scan code, and that scan code we have codified it to, because that value is going to be same. So here you can see in our, this, suppose if this is the switch which we want to press, corresponding to this switch, the value corresponding to P2.11 should be 1, and column number 1 should be 1. So row 2 should be 1, and column number 1 should be 1. So scan code which we are using in our program is as such written: C4, C3, C2, C1, R4, R3, R2, R1. This you can arrange in any way, either the row initially you can do, then later on comes the column. So in any way, it is not an hard and fast rule that always scan code should be like this. But in our program, we are using scan code, and we are making scan code in this way, and we will codify it, because 16 possibilities are there. Every possibility we have already codified. So in this case, corresponding to 4, the scan code is 12. So as you can see in the program, so scan code 0x12 in hexadecimal corresponding to ASCII code 4. So these are 2 codified arrays. Already we have codified it. So scan code we have codified it. So these are the 16 value corresponding to each codified value. These are the ASCII code which we will later on provide to our LCD display unit to display. So these are the ASCII code values corresponding to these specific ASCII codes, these specific scan codes. Okay. Now in our program, because we require 4 input pins, 4 output pins. So any program of interfacing start with the understanding of how many pins do we require. So in this case, we require in total 8 pins. Out of those 8 pins, 4 pins will be input pins, 4 pins will be output. Input pin we will always constantly monitor. Output pins we will regulate over a period of time. And how we will regulate those values? Suppose specific to row 1, if we want to check any column being pressed, so row 1 value should, row 1 corresponding pin should be 1. So here, as you can see, row 1 initially should be 1, then row 2 should be 1, then row 3 should be 1, then row 4 should be 1, and only one value should be 1. Either row 1, if row 1 is 1, then other thing should be 0. If row 2 is 1, other thing should be 0. Likewise for R3 and R4. Then exclusively we can monitor the column values. Then exclusively only one value over the columns will be 1, and then we can zero into the specific key being pressed. So this is the task which we will accomplish through our program. How we are doing it? So initially, this is of making. So this line is corresponding to making port number 2, and it's pin from 10 onwards till 13. We are making as row pins, and our row pins are output pins. So as you can see in here, these row pins, row 1, 2, 3, 4, these are connected to port number 2, pin number 10, 11, 12, 13. These are output pins. So over a period of time, you have to constantly keep on changing their values. And that value they will get from the core. So from core perspective, these are output pins because core is writing values over the pins, and core is constantly monitoring the input values over the pin number 1.23, 24, 25, and 26. Then so this line is to make those pins as output pins. So direction, we are setting the direction of GPIO2 as output direction. And this line, it isn't required, though you may write it, it is redundant in nature because already every pin of the port is input in nature. So because the value written over FIO direction is 0. 0 means it is input pin. So it is written. This is for initializing the LCD. So this is to do with LCD display that later on we will discuss. So these are all the LCD commands. So this later on, this LCD command is just to prepare our LCD for displaying the final output. Now the main program starts here with the 2 while loop. So initial infinite while loop, then inside the infinite while loop there is one more loop because constantly. So why this inside while loop is there? So this loop is here till I think here. This loop is here. So this while loop is to constantly regulate the value over the rows because constantly we want to engage our rows for checking whether anything being pressed over those rows or not. So how many rows are there? 4 rows are there. So we are constantly changing their value row 1 till row 4. So row is less than 5. So if initially row is equal to 1, then our variable is this. This is nothing. This variable is just to make port number 2.10 as 1. So if you will open the calculator and we'll copy this. So here, as you can see, no, it's not the value. 400. So here this is the binary. So 0 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So over the 10th value, over the 10th pin, the value will be 1. So this is for that purpose. So variable 1 is equal to this. Else if the row is equal to 2, then the variable 1 is equal to this. So it is nothing. If you will type over the calculator this value, then on the 11th pin the value will be 1. Likewise for row is equal to 3, over the 12th pin the value will be 1. For row is equal to 4, over the 13th pin the value will be 1. Then we are taking this variable in some temporary variable, and initially over the pin we are clearing the value. So from 2 pin number 10 to 11 we are clearing the value, we are making the value 0 over those pins, and then FIO set is equal to variable 1. Then we are enabling, we are setting that 1 over the corresponding row. If the row is equal to 1, so pin number 2.10 will be 1. If the row is equal to 2, pin 2.11 will be 1. If likewise for row is equal to 3, pin 2.12 will be 1. For row is equal to 4, pin 2.13 will be 1. So here that this is the thing which we are doing for a specific row corresponding to this program. So whatever be the row value, that thing we are taking in temporary one. Initially we are clearing it. So whatever be the initial value, we are making pin number 10, 11, 12, 13 or port number 2 as 0, and then we are setting it up. Initially the flag is 0, then we will monitor. So once you have set it, once you have set corresponding to row 1, then we will scan, because even idea is so, because the moment you have set the idea is so now once you have set the corresponding row as 1, then later on we have to scan whether anything over that row being pressed or not. So for that purpose there is a scan code. So we go to the scan code. What exactly we are doing in the scan code? Scan code is nothing for that. Once again, so suppose if corresponding to row 2, we want to check if any of these switch corresponding to 4, 5, 6, 7 being pressed or not. So at that time, what we have to monitor? We have to just monitor whether the value over these pins is 1 or not. If the value over these pin is 1, that means something being pressed. And what being pressed? So if the value over the pin number 23rd is 1, then 4 being pressed. If the value over the pin number 24th is 1, then 5 being pressed. Likewise 24, 6 being pressed, 25, 7 being pressed. So in this way, our core can then later on understand that what being pressed, and then can provide this to the output unit. So exactly the same we are doing here. So in TAM3, whatever be the value of GPIO1, because we are using port number 1, pin number 23rd onwards. So we are exactly taking all the 32 bits in temporary 3, and then we are extracting 23rd onwards value, because 23rd, 24, 25 and 26, these pins are of our interest. Other than this, we are not using it, because 23rd is for column number 1, 24th is for column number 2, 25th is for column number 3, and 26th is for column number 4. So we are extracting that value. So how you can see it? If we'll take this value of the and now you can see this is 23rd position, 23rd, 24th, 25th and 26th. So these 4 are 1 here, and this thing we are ending with TAM3. So we are extracting 23rd to 26th value, the bit value. And if this value is not equal to 0, that means something being pressed. Then we will toggle the flag, then flag is 1. And what exactly we are doing, whatever be the value, because it is 23rd onwards, that we are right shifting 19 times. why we are shifting 19 time? Because here is our scan code, because we have to now come up with a scan code. So in scan code, the column values are starting from fourth location, fourth, fifth, sixth, and seventh. So if anything which is there from the 23rd position, which is there from the 23rd, 24th, 25th, and 26th position, and that you have to start from the fourth position. So obviously 23 minus 4, that is 19. So 19 time we will shift. So this is the reason why we have shifted it 19 times. So M3 19 times. So now we are in the process of building our scan code. And this is the value. This is the temp value. This is the temp value which corresponds to row. So row 1, row 2, row 3, row 4. So that value is already there in temp 1. This thing we have to start from the 0th position, and it is starting from the 10th position in our temp variable. So we will shift it 10 times. Temp is shifted by 10 times, and in this way we can come up with a scan code C4. So this thing will come from the column values. So that means port number 1, pin number 23rd, 24th, 25th, 26th, and these row 4 onwards to row 1. This value will come from P2.10 onwards. So 10 times we will shift the row values that is there in the temp variable, and something which is corresponding to column is there in our temp3 variable, which we will shift 19 times, because that in the scan code we have to start from fourth location. Then our key is, now this is a scan code. So this is the way through which we are coming up with scan code. And then this is just the end of the scan code, means the scanning. Once scanning is over, so if at that time user has pressed something, so scan code will return the toggled flag value. So if the flag is 1, that means we will come out of this for loop. And then once again, if you will come out of the for loop or the first while loop, innermost while loop, once again we will check if the flag is 1. Once again we will come out of this while loop, and then now we are with our scan code. So now we are with our scan code out of these 16 values. Our next task is corresponding to this scan code, we have to come up with the ASCII code, and it is already there in codified form. So this exactly we are doing for I is equal to 0 to 16. If E is equal to scan code I, so we'll go and check. This is to find out the position over which the value exists, the scan code value exists. And then we will take in key the ASCII code I. So the moment, suppose in our program, we did this. So we did for this scan code, and this scan code exists on 0, 1, 2, 3, 4th position. And if you will do this, what? Yes, key is equal to ASCII code 4. So ASCII code 4 means 0, 1, 2, 3, 4. So this is the value which you will get in key. And then you will come up, and then finally you will display the same key over LCD. It is a simple program, very simple program. You can interface your key matrix with not only with LCD display unit, you can interface it through core with 7-segment. So anything which can produce output can be well interfaced through core with our key matrix. So key matrix can be used as input. So anything which you want to input, I mean it could be alphanumeric or anything which as per your logic you want to give and provide input to the core, and then you want to display and somehow use it through your logic. So it is very well on the programmer that how will you make good use of the 16 keys provided in LPC 1768 kit. So this is all about this program. We'll see you with some other interfacing in our next lecture.